Alright, here we go with a new video. Originally I was going to show you the next part of the truck setup with the ramp, the floor installation and so on. And in the end, I thought it would be good to take out the part about making the steel frame from this video. You need to make a steel frame, whether it's for a ramp hidden under a truck floor, a piece of furniture, a workbench, a table, whatever. The idea is to make a frame as flat as possible, whether it's wood or steel. I even want to say that with steel it's easier because with wood you have to plane it. You have to straighten it, you have to plane it, you have to trim it, it takes more technique. Steel stays relatively flat, straight and smooth. There's not much to do except clean it, strip it and weld it. So it's going to be easier. However, if we're working off a workbench, a table or even the floor, because in my case we're going to use the floor, since my ramp is going to be about 3 meters by 50 centimeters, I don't have a workbench big enough. So we'll use the floor. But the floor isn't completely flat. There are bound to be some differences in level. If your workbench is warped, if your surface is twisted, you'll lay down your steel, make your frame, put the brackets in place, no problem. You'll tack weld. The frame will take the shape of the warped surface, so your frame will be warped, and that's not the goal. So for that, there's a very simple technique. Whether it's on a warped workbench or a floor that's not completely flat because there are differences in level, we're going to use a pedestal for a terrace. It's really simple, but it's very useful because you can unscrew it and screw it back in. We'll be able to set it to the height we want using a laser. So you can use a laser, you can use a bubble level. In my case, it's going to be the laser, but the bubble level works too. And then we'll adjust all the other posts, so the other 3 posts, to the same height as the first one. And I want to have a surface that's going to be completely flat, even if the base, whether it's a board, a workbench, a table, or the floor, has some distortion. My posts themselves need to be level. And once they're level, I'll be able to place my steel bars, my boards, whatever. You use whatever you want to make your frame. And we'll be able to tack the steel bars and make sure the frame is super flat. So we'll still be able to adjust, raise, lower. Here, the goal is really just to tack first. So we don't overheat the steel, because the more it heats up, the more it might contract, shrink, expand, however you want to put it, and cause distortion. So the goal is really to have the flattest frame possible. So let's grab the camera. I'm going to take the camera. I'm going to turn the camera around. You're going to see the little setup I made with a board, some deck pedestals, and steel scraps. We're going to do a mock-up on this workbench using the laser and a wooden shim that I'm going to use. I'll explain to you later why I'm going to use it. And then we'll move to the floor full scale and we'll make the frame for the ramp for good. I'll show you on the floor. It's going to be exactly the same technique. You'll see we'll have a distortion-free frame. Let's go. Alright, here's a terrace pedestal. It's just plastic, nothing special. It's okay, it fits together, it screws in, it unscrews. We use it to build wooden decks. You place it directly on the ground. Sand, soil, concrete slabs, the joist on top, and then the decking boards. You can also use it for a concrete slab or a screed. You put down your mortar, set the right height, use the straight edge, and make the guides. Once that's done, you remove them and continue working along your guides. Okay, here I'm going to use it to make my frame. Here, it's just as an example. It's a 25mm steel bar, it's a leftover piece. This is just an example. We're not welding anything and I don't care about squareness or lighting. I only care about getting it level. So for that, we're going to use it. We're going to use the laser. We could use a bubble level, it would work the same way, but I think the laser is more precise. We're going to place the block, one here, one there, and one there. We're going to check that we're level. Lengths and widths. Okay. We're going to put it like this. Does it fit in the camera? Yes, we can see it. There. Here. And him, we're going to tear him apart. If he agrees. Like this. We don't care about the lighting at all. What matters to me is just the height. Of course, when we build the ramp, we'll check the lighting, we'll do everything together. You'll see. Right now I'm only interested in the height. So we need to use our imagination. Okay, so now we're going to adjust the height. So now that I know they're well positioned, we could screw them directly onto the board so they don't move. We remove it. We don't need the tubes. One important thing, if I can get it off, it needs to go in the middle. If you screw it in completely and you need to unscrew or screw this one, so unscrewing it will be fine. But if you need to screw it in because you still need to lower it, well, obviously at some point you'll get stuck. So it's good to put it in the middle to have some play. That way you can screw it in or unscrew it. There we go. Let's check that they're all about the same. In the middle, it's good. We're looking pretty good. So we're going to use the laser. We're going to put it in mode. Horizontal. In the middle. I could use a wooden wedge. The measuring tape, for example, tells me that the reference point is this one, and that at 2.4, I set all the others to 2.4. I'm not really a fan of that. I really prefer to use a wooden wedge, a scrap piece of wood. Use whatever you want and set it down. And we make a mark with a pen. Visually, it's much faster than measuring every time and saying, yeah, I'm at 2.4. So here we go with this one and we do it. Align, so these are our reference marks. And now I need to have the laser on this line each time, and I know I'm level. So this one, for example, I need to unscrew it. Up, and even a little bit more. There, we're good. It's on the laser line. I don't know if you can see, we can even position ourselves like this. This one, we're good. So this one, I can unscrew it a little. Yeah, it's actually the sticker you want. It's a bit loose, you got the idea. I could have taken it off because actually they all have stickers except this one. And the sticker, it's not a big deal. This one, it needs to be put back up. There, we're good. And this one, well, I'm turning my back to you, sorry. A little bit more.
There, how does that look?
We're almost there, just a little bit more, a little bit more. There, we're good. So you can't see this one, that's normal. It's facing away from the laser. Trust me, it's good. So here we're good, we're good. And we're good. So now that our laser is right on our mark, so we can put it back in place. Our tubes. There, okay, by the way, we can see that the laser line is good on the edge of the tube. Up, and there you go. Now I'm sure I'm level and we can notice something. I'll take them off again. It's this one. This one is hardly unscrewed while this one is completely unscrewed. Almost at least halfway compared to this one. So that means it's sloping over here. I really had to raise my frame here. So if I had based it on the slope, I would have had a warped frame no matter what. Because here it's completely screwed in. We're a little unscrewed. We're really unscrewed. And here we're less unscrewed than there. So I would have had something warped. So it's important to really make it level. Okay. So there you go. Now you know about the laser, the bubble level, the little shim, the feet. So the feet, they're called pedestals, deck supports. You can call them whatever you want. Pedestals, let's call them that. You use a shim, a pen, or a measuring tape. And there you go, you can measure. Here we're at 22.405 and here I'm at 22.45. Right? Here 22.4, okay, and here same thing, so we're good. I'm not really a fan of the tape measure because I think it's not, you can't really see well unless you're right on top of it. With this, you can't mess up. There's only one mark, the one I just made, so visually it's much faster. Okay, so now we're moving to full scale on the floor and doing the same thing again, but this time by checking the squareness, putting clamps everywhere, and then we tack it, we see how it turns out. Alright, we're starting with cleaning and cutting the steel bars thoroughly. They're 3 meters long per section. It's 30 millimeter square tubing. It's 3 millimeters thick. For what I'm going to do with it, that's more than enough for me. So I go straight to the floor. A sheet of drywall and a board to protect the tiles from welding splatter. Otherwise, I'll damage the tiles. I'll need to clean the bars because right now they're really dirty. And if I run my finger over it, acetone or metal degreaser works very well. Use whichever one suits you. And ideally, it's best to clean the bars now because once the frame is done, you'll have to turn it every which way and get into the corners. You clean the bar in one go and at least it's clean. You can handle it without getting your fingers dirty. Okay, so once it's cleaned, we're going to cut it. In the end, I made the decision. My frame is going to be 2 meters 70 by 60 wide. I didn't know if I should go with 50 or 70 at most. Alright, I'll split the difference. 60 is just fine, and for the length, 2 meters 70, so we clean it and then we cut. Who's getting several tips for the price of one? You are. I'll show you 2 more tips, then close up shop. I'm losing money here. The steel bar is placed in the vise. Okay, I'm not going to cut it flat like this one. I'm going to set it at an angle. It's much easier to cut that way. The blade, so the saw blade here, will attack the bar directly. If I set it flat, the blade will attack the steel flat. It's going to be harder to cut. So from an angle, it'll attack directly. I'll film it so you can see. Second tip, so I place the bar in the vise. Between the base of the vise and the flat plate, so the ground, I have 12 centimeters. And to prop up the bar, what do I use? Well, another block. It's back. We position the block at the correct height for the machine, no matter which machine you use. So we really use this level as our reference. And here's the result. Isn't life beautiful? Subtitle. The cuts are done. I've laid everything on the floor. That gives you an overview. 2 meters 70 by 60. 2 crossbars, that's more than enough. That gives me 1, 2, 3 areas where I'll put plywood. We're going to cut flat irons, so small flat iron tubes that will be welded onto the uprights. 1, 2, 3, 4, 5, 6 per area, and then I'll be able to screw the plywood directly, which will be flush with the uprights. That way, I can change it when it gets damaged, because here, with wheelbarrows and rolling trays carrying toolboxes, I'll definitely be working on it. So I'll damage the plywood, and I'll be glad to be able to change it. Here, it's open. On the other side, it's the same. The crossbars are inside the uprights. And here, it's also open. On the other side, it's the same. You'll understand later why, because I'm going to pass tiche vitae and croûte rondelle. We'll see that in a moment. I'll show you the machine. You've seen it in action, but I haven't told you about it. It's a Promac 349V. The link is in the description. I'm really happy with it. I've had it for years. It cuts really well. It doesn't make any sparks. It's absolutely not a dangerous machine. I removed the cover after changing the blade and never replaced it, so the blade occasionally jumps off. We loosen it here. We tighten it again once we've put the blade back on, and then it's ready to go again. You can add some oil. I didn't put any this time, and as you saw, it cuts very well. It makes clean square cuts. So of course you have to adjust it. You place a square against the vise and against the blade, and here we go. So now the task is to deburr each tube where it's going to be welded. We open all of this up, we deburr, we tack weld, and we see how it turns out. So now that the tubes are opened up, I've thoroughly used the abrasive disc where I need to weld. We're going to position the pads just like before. 1, 2, 3, 4. We're going to set 2 levels. Level. Here, I have a difference between the plasterboard and the chipboard. The reinforcement isn't flush with the pipe. I need to raise it up. So, as soon as we've adjusted the 4 corners, we'll tack it in place. So we're going to weld. Then I'll place a magnet on the tube, and it will be able to sit flush. Of course, I'm going to put brackets in the corners with clamps to get a perfect angle. We'll handle the corners first, then check the reinforcements. Everything is set, the pads are level with my laser line. So, the laser is here, the horizontal line. I'll take the shim again and show you. We position ourselves on this pad. The laser is right on the line. Or the line on the laser we have. There, we're good. And the other two? This. And impeccable. So all of that is done. Now, so let me make a quick side note because some of you might say, careful, at that length it'll sag. It doesn't flex at all. I'll show you. So I don't know if you can see it, but it doesn't flex at all. At worst, if it flexes, we'll use a brace, a wooden block, whatever. We place it on the floor, we raise it with a clamp, and that's it. I position the brackets and we start welding. So I made the tack welds on the outside, I welded on the inside. We'll check again with the spacer to make sure nothing has moved. It's important to check. We reposition the spacer according to the laser line. We're good. Perfect. We're all set. And perfect, we're good. So now I just have to finish. Welding and the crossbars too, and we'll be done. Alright, the frame is done. I removed the drywall and the particle board. I put the studs back. I'm taking the shim again. Let's check. Compared to my line and the laser, we're good. Here as well. We'll check the other two. Perfect. And the last one, we're good. The clamps, the squares, everything I used to make the frame, it's all in the description. So I could have used some clips and all, but for what I'm doing, this kind of clamp is more than enough. Next step, a bar in this direction. So I'm going to take a square piece, I'll cut it, make a U shape so the leg can fold into it. So plywood, plywood. The bar in this direction, plywood, plywood. We'll see about that soon. Alright, the frame is done. I'm satisfied with what I've done. It's ultra flat, there's no distortion. We'll meet again soon. We'll keep working on the frame, focusing on the leg. Because I want to take a square, cut it in half to make a U, and the leg will fold into this U. So there will be more welding. We'll tinker with some kind of attachment. Next, we take the ramp. We put it in the truck, the two rails on each side, we secure everything, and then we move forward with the floor. So the support was the star of this video. You need at least 4 of them. You hide them in your workshops, you take them out when you need them, but honestly they're super practical because here I used it for my steel frame. It could be a wooden frame, it could be for pouring a concrete slab, leveling a screed, a block, the reference point, we adjust the others. And then you just have to move forward. So if you have a floor that's a bit uneven, that's not flat, The blocks will save your life. So 4 blocks, it's not expensive. I'll put all the links in the description. Just like for the welding machine, the brackets, the clamps, you'll have everything. In the description of this video, you know everything. See you next week. We'll keep working on the ramp, the floor. In the meantime, take care of yourselves.